Academy Foundation presents Kinetic Singularity. Singularities are kinetic byproducts from common bubbles in hardness to obscure black holes. Mix ingredients, bake, and you have a singular cake. Edible or not, you just created a whole new identity axis out of potentially infinite combinations. Such generalizations of variability suddenly emerging as something else measurable are common in math and physics. Explaining it is hard when words get twisted. A dimension, for example, is not an alternate reality. Potentially infinite variation easily fits anything that can only be statistically inferred even in a clearly finite set. The most popular reduction is Einstein's field equations predicting a black hole. It applies to the Ricci tensor, which is the volume. This creates a potential in need of filling that is regulated by a surface tension. Reducing the scalar conversely provides a singularity volume. Each reduction has two possible outcomes, the nature determined by the third law of equal and opposite effects. Reduction to a volume singularity would be a degenerate density like a neutron star. When Wheeler coined the term black hole, he was thinking about pulsars as gravitationally collapsed objects. That is essentially the 18th century dark star idea. It is a uniform and static volume like a proton or atomic nuclide. Any value added applies around the object as a forced variable. This increases volume because the use of space is already maximized. All its dynamics are forced around it. Degenerate densities are basically points of spatial volume to add or connect with. Conversely, degeneracy pressure like electrons is a spatial hypersurface. Adding value affects the volume, causing it to contract. Atoms thus consist of two opposite types of spatial singularity. Ironically, to cover the most familiar and boring singularities, we start with the fun one. This is the Crab Nebula Pulsar in time-elapse photography. To do the same with a black hole would require an unknown number of billions of years. We don't have that kind of time. Following the third law of equal and opposite effects, we are seeing a volume effect of matter creating a temporal hypersurface. The mixing angle effect on Newton's constant is a whole other story, so let us hide that distraction. It is easy enough to play with the math to see how these singularities relate using Einstein's field equations. It shows where constants force definition dependent on specific channels of value input. Black holes are incorrectly associated with supernovas due to Wheeler's understandable confusion with pulsars and neutron stars. A pulsar needs to be fed, and to keep pulsing, it needs to not blast everything it is fed so far away it cannot refeed itself, setting aside the theatrics. It is the fully occupied volume field condition of a neutron star. It is a Ricci tensor form of singularity. It was forged in the explosion and can act as a nucleation point for forming another body. The hypersurface, making it a pulsar, requires sustained kinetic energy. For a black hole, this is the main feature. For a pulsar, it is a part of the forced variable projection around the object. This is the coma cluster. In 1933, Fritz Zwicky measured the kinetic energy and set off a storm of controversy we know today as dark matter. Kinetic energy is the energy of motion. Let's put this problem in human terms. One person by themselves can only eat and do so much. The person has a mass in kilograms. The action of the person also contains the unit kilograms, but that doesn't mean the action is a measure of being a person, only that the measure is in some way compatible with a measure of a person. One crab gets a big idea, and that action increases his effect in the universe exponentially. Put into context of a village, the effect increases exponentially again. Community is a form of kinetic gravity. Its solidarity or cohesion is a form of singularity. If Eugene Crabbe is our thesis, then his idea of a Krusty Krab restaurant is the antithesis. We cannot see or measure this idea without him acting to form the bicomplex. This action is kinetic energy, and the formation is a form of gravity pulling it together. And again, just because you weigh the person in kilograms doesn't mean the action measured also in kilograms means a measure of people. It is a measure of action. A community of people is held together by its common actions. This applies to every level of matter as well. Contrary to the popular opinion making a mess of entropy, the universe does not favor chaos. It just doesn't care what our definition of chaos is. Here is a common mistake. The human idea of tidiness is only slightly relevant to entropy. This slide and this slide are common ways to incorrectly explain entropy. This is the correct way. As entropy approaches 0, the uniformity of action forms a solid. As entropy approaches 1, each molecule's energy and direction is independent from the others. The geometry and organization of the parts is only a small factor in this. The result, either way, is isolation to one dimension consistent with singularity. Bubbles are filled with disordered gas. Despite the independence of the parts, a context enables a uniform identity. Only the context and degree of common motion matter. 1.2 billion light years is the difference between C and B and the light horizon. It is also the limit to clusters, filaments, and walls. Time contracts, space expands. When the landscape is primarily time, then an ideal absence of matter creates a context of contraction. Dilation, like this, extreme, indicates an ideal absence of mass, not a presence of matter. Dark matter cloud is a misnomer. This is dilation. Temporal clouds, if you will. The openness of time in this space is greater than the spaces around it. That creates a gravitational lensing effect from a volume form of temporal singularity created by the flow of galactic clusters and filaments. All you need for singularity is to isolate input into one dimension. That dimension will be a surface or volume, angular or linear. One dimension breaks down in bicomplex logic to an element of a change function. It is standing and valuing an inert space. The first two rows are hypersurface and volume forms of singularities. Pressure as surface tension is first. It is the most elementary form of gravity, often called quantum gravity. Then come temperature, flexion, hardness, adhesion, and cohesion. The next row are their volume forms. In particle physics, these are called Fermi surfaces and Weyl fermions. When the energy is applied to an individual apart from the group, or the group as a unit, it will affect motion. Action on a group tends towards equilibrium within the group, affecting the spaces among the parts. Connecting those details with common features leads to practical engineering. While not as entertaining as a black hole, the hardness of these rocks is a common hypersurface feature, regulated by the same principles of kinetics. Consider our thesis' hardness of ice being a static pressure surface describing a group of molecules. The universe loves functional synthesis. The absence of dynamic volume invites that kind of value. Typical singularities may seem mundane, but they help see how those we can't directly emulate also work without breaking the laws of physics or reason. Quantum relativity conceptualizes advanced topics in established physics to provide educational and practical tools. Our biggest problems in physics are human, specifically too much information and no accurate standardization of the concepts. Basically, advanced physics needs an introductory class to put it all together. Remember to subscribe and stay tuned for other educational videos. Thank you.